This is Lab 4, Arithmetic Logic Unit. These first 4 switches on the left are inputted as A. These next 4 are inputted as B. The last 3 switches on the right-hand side are signify the command. For instance, addition, subtraction, incrementing, your logic. When you're doing them, the data out will be signified with these 4 LEDs. This LED stands for carry out. The one after is negative. The next one is overflow, and this is 0. This is currently 0 if no switches down, because no switches means 0 plus 0. Since these 3 are all down, it will be 0. For instance, if we do 4 plus 4, or 2 plus 2, it would end up giving us 4. The next command is subtraction, which is this first switch being up. This signifies that it's 8 minus 1. These 3 LEDs signify 7 in binary. Shows that there's an overflow of 1, or a carry out, my fault, and an overflow. There is no 0, and it's not negative. When subtracting a negative to a positive, for instance, negative 6, signified by A, subtracted by 5, signified by B, of course, the subtraction switches up, it will give you negative 11, which is these 3, including carry out, so it'll be 1, 0, 1, 0, 1, and then the negative LED is flipped up as well. The next command is incrementing, which is this switch. It deals with just the A, and it increases by 1. For instance, this is all 0, so it shows a 1. If we put a 1 in here, it should show a 2. If we do 3, or if we do 2 in A, it'll show a 3 in here. If we do 4, or no, if we do 3 in here, show 4, and so on and so on. The next case is going to be a logic system AND. These are all 4 switches are up for A, and all 4 of these switches up for B. Since these are exactly the same, it should give us a 1, which is demonstrating an output of the data out. It shows all 1s, but if we change one of these, the next command is AND. Since A matches up with B in this case, it signifies here that they're all 1s. If we change it up to, let's just say we do this, 1, 0, 1, 0, 0, 1, 0, 1, it shows that they're not ANDed together, or they're not the same. So these are all 0s. The next case is OR. So regardless of if one of these 4 bits are up, it'll be all 1s on this case. So if this was down, none of the 3rd bit of A or B is up, so that would be 0. But since the 1st bit and the 3rd bit are up for A, and the 4th bit is up for B, shows that the 1st bit, 3rd bit, and 4th bit are 1. The next command is XOR. A being 1, 1, 1, 1, and B being 0, 1, 0, 1, it gives us 1, 0, 1, 0. The final case is not. B is irrelevant in this case, since we're only working with A. So as you can see, for all 4 switches, it's a 1, but for the 4 LEDs, it's all zeros. If we flip this down, this bit down, it gives us a 1 on the other side. And that'll be the case for all of them, even if we have them all down. If we have them all up, it even gives us our flag to be, our 0 flag to be 1.